we have talked about this a lot. So today we are going to start the next section of physics, which is the electricity. My least favourite thing to teach, I think, possibly. Except today's lesson. Because I get to blow up a balloon. So, balloons and electricity. Why? Static. What is static? Electricity. Yes. Could you perhaps answer the question without using the word electricity?
Power.
Energy. Power is energy. Okay. You're now throwing out random important physics words at me.
Sulfur acid.
Sulfur acid. That's chemistry, and sulfur is an element, and acid is a general term. Did you mean to say sulfuric acid? Crushed. Good. Some sense, please, William. Yeah.
I'm not sure, but the static electricity is built by friction.
Okay. So what have I got to do to the balloon to get it to be statified?
I think rub it onto your hair.
You would suggest my hair, wouldn't you? Okay. Is it static?
Yeah.
Yeah. Why are you not laughing? So, what has happened? What's going on in the world that we cannot see because it is so tiny that this and this have interacted in a way that my hair is standing on end? Why?
Electrons.
Good. If you're in doubt, and the physics teacher has asked a question, electrons is a good start. Doing what? Moving. Yeah. Where?
Yes.
Come on. Let's say the electrons on the balloon. Where are they in the balloon? On the balloon. Where exactly? On the surface. Just there. Are they there usually? Where do they normally live? We did chemistry, in which we discussed that the electrons were around the atom. Yeah, so they're around the nucleus of the atom. So they're in the atoms ordinarily. Yeah. Start up some friction, and some of those electrons get moved. Yeah. So the friction moves the electrons. So the rubbing friction there is either ripping electrons from the surface atomed outer shells and putting them on my head, from the balloon to the head, or it's doing it for the hair and putting them on the balloon. So there's either more electrons on the balloon or more electrons on my hair.
Why doesn't it work with paper and stuff?
Any suggestions? Why doesn't it work with paper? Why doesn't it work with metal foil? Yeah.
Since paper is insulator, so it doesn't really conduct that.
What's that made out of?
Plastic.
Plastic, which is a yeah. Paper is a better conductor than the plastic. That's why it works. Metal foil, a metal balloon, it's not going to work because the metal is a better conductor. Okay, I've chosen this because it is an insulator. So the electrons, let's say the electrons are on the balloon, they are staying on the balloon. They do want to get away from the balloon because actually electrons are really antisocial to each other. They hate each other. Like charges repel. They don't want to be together. So actually I can feel this balloon is trying to attract itself to me. Which is amazing. It actually have a pulling force towards me on the balloon because it wants to get rid of the electrons to join up with the absence of electrons on my hair. Does that make sense? Because my hair is positively charged. Yeah. Okay. And I can do that with my hair, or I can either have a stream of water, and I can make the water move. Okay. Okay, so the water has actually taken away some of the charges. There might still be some charges on there, so it's still stay up there. Normally the static is something we don't want because we don't want to look an idiot with our hair standing on it. So you could have anti-static shampoos or gels and all like that. Okay, that's a tiny amount of static. Let's make some more. Oh, my static making machine. Now, sadly, the temperature has gone above 0, so there is a little bit more moisture in the atmosphere. Why does that matter? Well, you saw how the water moved towards the balloon, and the water actually tries to conduct away the static, so I'm not sure how well this is going to work today.
We did that in my old school, so can we do the thing where everybody like holds hands and one touch it and it runs to everybody?
No, because it is illegal.
Why?
Which old school was that?
In Luxembourg.
Luxembourg, yeah, okay. No, that's actually one thing I won't do with it,
Why is it illegal?
because it could kill you. Because some kid once died because of it. Because if any electric shock is possibly going to be fatal, believe it or not. Even walking along, touching this. If you get to it at the wrong point, you've got a history of heart disease, then it can kill you. What you have to do is learn how to handle these shocks, as you'll see from me, so that they don't go through the main pathway across your body, crossing your heart. And when everybody sits in the ring and holds hands and gets a shock, it goes straight through heart. So that actually got banned. And I must admit, I'm not prepared to do it. I've spent a lifetime telling physics teachers off because they're like, oh, don't tell the boss, but we shouldn't do this. But you will get an opportunity, if you wish, to shock yourself.
Doesn't it work?
If it's working. If it's
If
working.
you put your hand on it, all your hair like goes like really, really thick.
Hopefully. Hopefully. Now, I am wearing a cotton shirt, so I decided, as it was damp outside, maybe this would be better, because it is more static. Okay. It was the first thing I could find, and that was staticky. So, I want to give myself some nice shocks. I am insulating myself from electricity leaking away. Yeah, did you see with the balloon, as more water got attracted to it, then the force of attraction dropped off and the trail of the water dripped away? Did you see that? It got weaker as time went on. Because electricity does leak away. That will fall off the wall eventually. Okay, I want to trap some electricity on me. Now, if you wish, you can come and gather around so you are closer. Not too close. So, for static, I need friction. Here, have inside this perspective, you see they've got the tube, we have a rubber band. There's a motor at the bottom controlled by the electricity here. Turn the motor, and then the electrons, the charges, go up to the dome, the outside of the dome. And the idea is that the hair stands on end, and I'm not feeling the joy at the moment. Is it working?
No.
A bit.
No.
Until they have. They usually have that.
No, this is bad. Stop breathing, stop producing liquid. Hang on. A few little bits. Okay. I'm going to make sure that I get the electricity off of here by providing what's called an earth connection. I'll talk about that in a minute. It's not dangerous. Yeah, yes, well done, well done. Going to just check, is that? Aha. It's warmer, so the it's warmer, so actually it's expanded, it's got a little bit tighter. Come on! That's not good. Oh, come on, please.
Yeah, something about Lee.
I don't believe this, it was brilliant. Work down here. So sorry about this. It was turning first off, wasn't it? I'm gonna burn the motor up, I'm not careful. Bugger. Go back to your places, amuse yourselves for a couple of minutes. Oh, I am not such a happy person. If I go bang, clear up the mess nicely. Darn. I might have to show you a video instead. No, something is seriously odd about it. I wonder if some vile person has experimented with it. Can't guarantee this is going to work. You shouldn't be making that mistake, obviously. Right, really sorry about the noise. It saves taking its bits and fixing it properly. Right, this noise is going to completely do my head in. Did you see some sparks? Good. No? No, I bet you did. You just want me to do it again.
You get a shock.
Yeah. Okay, so I am. Hopefully not. I'm going to have to shout above the noise. I'm really sorry about that. Now it's turning, and I've made a better connection on the inside so that the rubber belt is now it's now got a wire connecting it to the dome. When it's turning, the static is going to gather on the dome. And this is insulated from the rest of the world by this Perspex non-conductor. So the electricity spreads over the metal. But it wants to get away, it wants to go somewhere else because these electrons don't like each other. So you might feel a little bit of a breeze. I will feel a little bit of a breeze as my hair stands on end as my hand approaches it. When there's too much electricity, the actual air will break down, and at that point, every centimetre has got 10,000 volts across it. So the sparks, if they're a centimetre long, that's 10,000 volts.
And it wants to what?
And suddenly, it's not making a noise. Okay. So, oh, so what's happening? Every time there's a spark, every time there's a spark, every time there's a spark, the electricity goes to me, it stays on me, it stays on me, and my hair sparks up, okay? So I am now carrying some electricity. It's quite a lot of electricity, and in fact, it wants to get away from me, and you might be able to hear clicking on the floor. Yeah.
Are you standing on styrofoam?
I am standing on styrofoam to insulate myself. I am standing in Crocs. However, I am actually getting electric shocks coming through my toes, going to Earth. Okay, my balance is actually really, really bad, as you know,
Oh, if somebody touches it,
but I will try.
what happens?